Talking about arithmetic sequences and series. Y'all say that word, arithmetic.
Arithmetic.
What does that look like? What word does that look like? Arithmetic, right? It's spelled exactly the same as arithmetic, and it means the same thing, except we're using it as an adjective, not a noun, so we say arithmetic. Didn't know you was going to get an English lesson today, did you? Okay, so arithmetic is a noun, arithmetic is an adjective. Adjective describes something, right? So we're going to talk about arithmetic sequences and series. An arithmetic sequence is a sequence, now a sequence, y'all, is a list of numbers, right, in order, in which the difference of consecutive terms is constant. That means the number of terms that it goes in is constant rate. It's going up by the same amount or going down by the same amount every single time. The difference is called the common difference. Okay, they call that little d. So anytime you see that lowercase d, that means the common difference. So for example, here's a sequence right here. 1, 2, 3, 4, 5. And the dot, dot, dot means it goes on forever. It's continuous. Okay? Now, I'm not seeing all my toolbars. Let me get all my stuff, y'all. Few toolbars. Okay, so notice from 1 to 2 and 2 to 3, what's happening to those numbers every time?
They're going up by 1.
They're going up by 1. So the common difference for this series or this sequence is 1. D equals 1. It's the number that you're adding every single time. Okay, hang on. I've not got to that yet.
You got to it yet, girl.
All right, so you can have a negative common difference. Okay, so if it's decreasing as you go, you can have a negative common difference. Okay, so your D will be a negative number. So next they're going to give us a sequence, and we have to determine whether or not the sequence is arithmetic. Now remember, for it to be arithmetic, then it needs to be increasing or decreasing by the same amount every single time. So what do I add to 7 to get to 13?
6.
Plus 6. And if I add 6, do I get 19? And if I add 6, do I get 25?
Yep.
Yes. So this one is adding by the same amount every time. So yes, this is arithmetic. And the common difference is 6. Okay. So whatever you're adding to get to the next term every time, that's your common difference. He is. He's so intelligent.
I'm so intelligent.
He loves to know that his voice is getting recorded and it's going to YouTube too. That makes him all excited. That's why he does it so loudly and proudly.
Follow me on Instagram.
All right. I'll put a link in my bio.
Funny. King B66.
It's just Mrs. _ Isbell. All right. So the next sequence right here, we want to know, is it arithmetic? So from -8 to -4, what happens there?
Down 4.
It went up. No, it didn't go down. It added 4. From -4 to 0, it did what? So what about 0 to 6? And what about 6 to 12? So did it add the same thing every time? No, so this one is not arithmetic. Okay? So for it to be arithmetic, you have to be going up or going down by the same number every single time. Okay? All right. So here's a good formula for you guys to memorize. So if we have a sequence and we want to find a certain number term of the sequence, this is the formula we use. A sub n, we call it sub n. That means the nth term. A sub n. That means it's below, subscript. Okay? A sub n equals A sub 1 plus n minus 1 times d. It's like a little cheer. It kind of gets a little rhythm going. A sub n equals A sub 1 plus n minus 1 times d. A sub n equals A sub 1 times n minus 1, plus n minus 1 times d. Said it wrong. Okay? That means the nth term, that's what A sub n means, equals A sub 1. Now, A sub 1 means the first term.
First term.
First term.
Number 1.
N is the number of terms, so you take however many terms you have and subtract from 1, or 1 from it. And what is D? Same thing D is being. What is D?
The common difference.
What does the common difference mean?
Difference in terms.
What is it?
How much you add?
How much you add or subtract to get from one term to the next in your sequence. That's it. Okay? So y'all get all that written down and let me know when you got it.
You don't need a calculator.
I don't, but you might. I got my calculator.
I ain't got my calculator. I'm gonna go get me one.
No. I hope that works.
There's my calculator right here.
Yeah, that one just broke. Yeah, and if one of y'all would like to borrow one, that's fine. Just put it back in the spot you got it, and it'll be fine.
Yeah.
I share.
Sometimes.
Sometimes I do. Sometimes I don't play well with others. Okay, does everybody have that formula written down? A sub n equals A sub 1 plus n minus 1 times D. So they're going to start by giving us a sequence of numbers. And then they want us to find a certain term in this sequence. So they have given us the sequence -4, 1, 6, 11, 16, ... means it goes on forever, going the same way, same pattern. And they want us to find the 45th term. Now, what we need to do is find out the common difference. That means what is going up every single time. So what are we doing every single time from one number to the next? We're adding 5. Do y'all agree? So my common difference is D equals 5. Now, I could, to get the 45th term, keep adding 5 till I have 45 terms, right? I ain't doing that.
That's too much work.
You crazy.
Okay.
I ain't doing it. Okay? So what I can do to do it is use this formula. Okay? So if I want to find the 45th term, my n is 45. Right? If I want to find the 45th term, my n is 45. My a sub 1 is the first term. What's the first term they gave me?
-4.
-4. It's the first one they gave me. Jared, I'm not doing that. I just said I'm not doing that. All right? So, the first term is -4. I'm going to use that there. N is going to be 45. So, I'll say 45 minus 1, which is 44. D is the common difference. We said we're adding 5 every time. Right? So, let's just plug all that in. Here's my formula again. A sub n equals A sub 1 plus n minus 1 times D. That's what that is. A sub 1 means the first term. So the 45th term, that's what that means, equals, what do we say is the first term?
-4.
Plus, what's my n if I'm finding the 45th term?
45.
Minus 1 times what's D?
5. Plus
5. All right. So, subtract that. What's 45 minus 1?
44.
So the 45th term is going to be -4 plus 45 times 5. What's 45 times 5? Somebody? What's 44 times 5? Yes.
220.
220. Good thing you guys calculated. And then you just add -4 plus 220, and what do we get? So the 45th term in this sequence is 215. And that's how you do it. Your n is the number term you're looking for. Your a sub 1 is your first term. And your d is your common difference. What's going up every time. Or you could be going down. So any questions on how we got that? So if I would have took that and just added 5 45 times, I'm going to get to 216. It's going to take me all day, but I'll get there. All right, so the next thing we're going to do is something different. The next thing we're going to do is write the rule. Write the rule. Now that means we have to come up with the formula to get the next term. Okay? So if you think it says write a rule, that means you have to write an equation of how you're going to get the next term. So we're starting out -7, then -10, then -13, then we're going to -16. What are we doing every time? We're going up, we're going down. We're going down by 3. So our D, our common difference, is -3, right? Because adding -3 is the same thing as subtracting 3, right? So there's my common difference. And we're going to use this formula, A sub n equals A sub 1 plus n minus 1 times D. But we don't know what n is. Because the rule means we're finding for any term. We're finding it for the nth term. So we're not going to know what n is, but we're going to write a rule for whatever n is. So we're just going to leave it A sub n equals, what's our A sub 1? What does A sub 1 mean?
The first one.
The first one.
-7.
Very good. So -7 is my first one. Plus parentheses. We don't know what n is. Sorry, I marked through that. So I can't do n minus 1. So I'm going to leave that n minus 1. But I do know what my D is. What's my D?
-3.
-3. So I'm going to keep my -7 out here. And I'm going to distribute this -3. Even though it's kind of reversed the way it's written, it doesn't really look like distributive property.
3n, -3.
-3n. Well, what's a negative times a negative? Plus 3. You do. And a bag of chips, right? So then I have my like terms, -7 plus 3. And what is that? -4. So my rule is, whatever the nth term, I can get it by saying -3 times n minus 4. This is my rule. Okay? So I can find whatever term I want to find by plugging n in right here. Okay, there's my rule. But it wants me to then find A sub 20. That means find what term? The 20th term. Right? So A sub 20 is going to be -3 times, I'm using this formula right here that I just made up. I didn't make it up. I used my original formula to get it. -3 times 20 minus 4. So I made the rule first, and now I want to find the 20th term, so I just plug 20 in for my n. Does that make sense? So what is -3 times 20? And what's -60 minus 4? Try again. -64, yeah. They're the same sign. So the 20th term will be -64. So
You only have to do that when it's negative.
you only have to do what when it's negative?
Make your own rule.
No, you only have to make your, it said write a rule, and that's how I have to make my own rule when it says write a rule. Okay? And plus, they didn't specify what n was to start with. Does that make sense? If they don't give you n to start with, then that's how you do it. Okay? It says write a rule and then find A sub 20. So this is how I had to get my rule because I didn't know what n was to start with. So that's why I had to distribute right here and solve it in terms of n. And then after I know what an n is, they said then find A sub 20. Then I plugged 20 in and got what A sub 20 would be, the 20th term. Let's do another one like this one. Same kind of problem. It's just another example. It says write a rule for the nth term of the sequence and then find a sub 20. So we're finding a sub 20 again, but we also have to find our own rule for this sequence. So we're going to use that same formula. A sub n equals a sub 1 times n minus 1. That's supposed to be plus n minus 1 times d. I keep forgetting my plus sign. Forgive me. So, we got to find, we know what a sub 1 is, don't we? What does a sub 1 mean? It's the first term, isn't it? A sub 1 is always the first term. So I'm writing a rule, so I'm going to keep these n's. So a sub 1 is 59 plus, I don't know n, so I'll leave that n minus 1 time for right now. And what's my d? How do y'all get 9? Right, you see what number it goes and what you have to do from this number to get to this one and so on and so on. And it should be the same every time because these are arithmetic. All right, and so you simplify this by distributing the 9. So keep your 59. And then 9 times n.
9n.
Very good.
-9.
And then negative 1 times n, negative 9. Then what do we do, y'all?
Like terms.
Like terms. What's 59 minus 9? 50. So the rule for this one is a sub n equals 9n plus 50. So there's my rule.
Now we got to do the other.
Yeah. So any questions on how we got our rule? So now if we want to find the 20th term, all we do is plug 20 in for n to our rule. So 9 times 20 plus 50. And what is 9 times 20? 180. Very good. Plus 50 equals what? 230. So my 20th term will be 230. So here's my rule that I got by plugging in my a sub 1 and my d. And then I figured out that rule, and then I wanted to find the 20th term, so I just put 20 in for n. Okay? Very good. Any questions on those? Okay. Now here's where it might get a little confusing. Yeah. We'll have 2 examples like this. It tells me the 27th term is 263. And the common difference is 11. Write a rule for the nth term. So I'm still writing a rule, but I don't know the first term, do I? No, because they did not give me the sequence. Usually they've been giving us the start of a sequence. They didn't give me that, so I don't know the first term. But I have to write a rule for it. But before I find a rule, I got to first find the first term, right? Because you got to have a sub 1 to use the formula to get your rule. But I do know that the 27th term is 263, right? And I also know that my d is 11. So I'm going to use that same formula. A sub n equals a sub 1 plus n minus 1 times d. Yeah, so now a sub 27, I know that, equals a sub 1 plus my n for my 27th term was 27, right? And it says my d is 11. So I do know when n is 27 that term is 263, right?
Yep.
Let me rephrase that. I know that the 27th term is 263. Okay? So I'm going to substitute that right here. 263 equals a sub 1 plus, let's go ahead and finish this. What's 27 minus 1? So 263 equals a sub 1 plus, what's 26 times 11? And how do I solve that for a sub 1? How do I get that by itself? Both both sides. Very good. I'm going to have a negative a sub 1. That's okay, because sometimes we start out negative. It's negative 23. So my first term was negative 23. So I've done all this to get my first term so that I can plug it back into my formula to get my rule. Okay? So I didn't have my first term. I had a term in my series, in my sequence. Okay? So I just had a random 27th term. That's all I had. So I plugged that in to get my first term. So now that I know my first term, I can plug it in to get a rule. So remember, a sub n equals a sub 1 plus n minus 1 times d. Hopefully we're memorizing that by now. We've written it 50,000 times. So remember, for my rule, we're going to leave all the n's ends, right?
Yeah.
So a sub n equals, now we know a sub 1, my first term. What is my first term that I found?
23.
We found out it's negative 23. Plus, we still don't know what n is. We're keeping ends. Times my d is still going to be what? 11. And this is the one where we have to distribute the 11 times n minus 1. So a sub n equals negative 23. 11 times n is 11n. And what's 11 times negative 1? Minus 11. Very good. And negative 23 minus 11 is what? Very good. So my rule is a sub n equals 11n minus 34. That's my rule. So this, when you don't know your leading term, your first term, that makes it a little bit longer process to find your rule. Okay, and that's all we had to do on that one was write the rule. They didn't want a special term. They just wanted the rule. Okay. Any questions? So we took a random term they gave us, which was the 27th term, filled it in, got our first term, and then after we got the first term, then we found the rule for all of the terms. Okay. Let's do that again. Different problem, same type, but different problem. Then y'all gonna feel smart with our summation stuff. Summations. Excited. I feel smart teaching it. All right, this time they told us the 19th term is 48 for some series. So we don't know anything about the series except for the 19th term is 48, and it has a common difference of 3. So before I can write a rule, I have to find what number term? The first one, right? Because I got to have a sub 1 to write the rule. So I'm going to first find a sub 1. So the way I find a sub 1 is a sub n equals a sub 1 plus n minus 1 times d. I know the 19th term. So I'm going to use n equals 19. So a sub 19 equals a sub 1 plus 19 minus 1 times what's my d on this one? 3. This is 3. And we know that a sub 19 is 48. And then I just do my arithmetic. 19 minus 1 equals 18. 18 times 3. 54. Now, how do I get a sub 1 by itself? Subtract 54 on each side. And 48 minus 54 is what? Negative 6. Very good. So our first term is negative 6. So after I found my leading term, now I can write my rule. And that's when you leave ends alone. You leave ends to be ends. Now remind me after the lesson to tell you about my child. Funny, not so funny story. He's in trouble. I'll tell you later. All right, so now we got the leading term. We can write the rule. A sub n equals A sub 1 plus n minus 1 times... Yes. So leave your n's alone. All you plug in when you're writing the rules, A sub 1 and b. That's all you plug in. Leave n's alone. So A sub n equals, what's A sub 1? We found that one. Plus, leave it in, you're ahead of me, times 3. D is 3, right? Distribute this side. So A sub n equals negative 6 plus, distribute, 3 times n is 3 times negative 1. And then combine your like terms. So A sub n equals 3n minus 9. And there's my rule. Good job. Oh my goodness. Extra, extra, extra. I'm there. You got it, Jared? Okay. Y'all go ahead and write that definition, please. I'll give you a minute or two. We're kind of switching gears just a little. We don't like much, like 2 more examples, I promise. But y'all got to write down a few little terms first. Oh, yeah, 2 examples, and then we're done. So those were arithmetic sequences. Okay? So the next thing we're going to talk about is an arithmetic series. So a sequence, you're just listing terms. You're doing the same thing to it over and over, but you're just listing the terms. A series you get when you add all the terms together. So you're wanting a sum of all your terms. So an arithmetic series is when you add all your terms in an arithmetic sequence. Now, it's kind of hard to add to infinity, right? Right? Because series really go on forever. And sequences really go on forever. So what we want is a stopping point somewhere. We're going to add all the terms from the first term through the 100th term. Okay? Because, I mean, if not, it's infinite. And so that's kind of difficult. So we're going to find them for a finite series. Finite means it's countable. Finite means it stops. It doesn't repeat forever. Right? Right?
Yes, ma'am.
Like our mortal bodies are finite. One day it's going to give out and croak. Huh? And they're going to put me in the ground. Right?
They're going to put me in the
ground. Right? Okay. So finite means it stops. Infinite means it goes on forever. Right? Okay. So let's just talk about, here's a sequence right here. It's arithmetic. It goes up by 2 every time. 2, 4, 6, 8. Goes on and on. Right? That's a sequence. Now, if I added all of those terms, that would be the series. Okay, so that's the difference in a sequence and a series. Sequence is just a list of numbers. Series is when you continually add them. So, here's our formula for how to find the sum of a finite arithmetic sequence. Now, I gave you a little key over here. Here's another formula for us to memorize and put it into our bank of knowledge that we may or may not ever use again in our life. Pass this class. Do what? I would, because that tells you what to put over there. Yeah, the reds is just as important as that, because that way you know what to put. So it's S of n, that means the number of terms you have, equals that number times This is basically the average. Do what? I'm moving. Am I good? Okay. So you're going to add the first term and your last term and divide by 2, and then multiply it times the number of terms you have. I'm going to raise it on up. I just didn't want to freak y'all out by this Greek symbol right here. Y'all are learning Greek. Alpha, beta, gamma, delta. Something, something, zeta, eta, theta, bar.
Did you say big, baby?
It's kind of like an E or a backwards 3, but it's the Greek capital letter called sigma. And we use the capital letter of sigma in math class to mean the sum.
You in college, man?
Yeah, I'm college educated.
You know what I'm saying?
About a couple times. Yeah.
What they mean, though?
Are you talking about a fraternity symbol?
Yeah.
Yes. Fraternities and sororities are made out of Greek letters and that Greek alphabet. Yes, I know.
I'm going to Jackson State.
Anyways. So are other organizations and clubs on college campuses. I could go into the history of that, but I won't.
I'm going to college.
All right. So, Pi Kappa Alpha. All right. So, if you see this symbol, it looks like an E, and it's a backwards 3 kind of, but it's kind of jagged. It means sigma, and in math, that means the sum of something. Okay? It means the sum of something. Sum means you do what operation?
Add.
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 Okay. So, did y'all write this down? N is number of terms. A sub 1 is the first one. A sub n is the last one. Okay. So, this is how these problems are written for these series. This just means sum. Okay? This means sum. The 20 means the 20th term. This is the number term you want. This is the rule. Okay? This is actually not the number term. It's actually the last term. So if y'all fix that, I don't want to be incorrect. This is the last term. So the 20th term will be our last term. This I equals 1. I means initial. Y'all know what initial means? It means what you're starting with. It's the beginning. Okay? So this is where you're starting. This looks like Greek because it is. Haha. Sigma. Okay? But it just means what we want to do is we want to find the sum of this series. That means we're going to add all the numbers from the first term of this series to the last term of this series, which is 20. So we're going to start with 1 and go to 20 and add them all together. Well, here's the rule for it. And we also have this formula for it too. S sub n equals n, parentheses, a sub 1 plus a sub n divided by 2. It's basically n times the average of the first plus the last. The first and the last. N times the average. Because if I take two things and add it together and divide it by 2, I'm finding their average. Right?
Yes, ma'am. Yeah.
So, that's what I'm going to do. I need to find the first term and the last term. So, to find your first term, this right here tells you what your first term is. I equals number. Well, that number is your first term. Well, this says I equals 1. So, what's my first term?
1.
1. And we're going to use the rule. And the rule is this.
3 plus 5, 1. I mean 5.
Yeah. So, I'm going to use the rule. A sub 1 is going to be 3 plus 5 times 1. It's going to be my first term. So, 5 times 1 is?
5.
Plus 3 is what?
8.
8. So, my first term is 8. my last term will be n equals 20. So a sub 20 will be 3 plus 5. Well, 5 times 20, isn't that 100? Okay. And 3 plus 100 is 103. So there's my last term. So all you do is fill those into this formula to get the sum of the series. So it stops at 20. So 20 is my n. My first term was a sub 1. That was 8. A sub 20 is 103. And then divide by 2. What's 8 plus 103? 111. So it's going to be 20 times 111 divided by 2. What's 111 divided by 2? Is it 55.5? Sure is. So then you're going to do 20 times 55 and a half. Can y'all do that for me?
Yes. 1110.
1,110. So if I add all the terms in this series, or in this sequence, between the first term and the 20th term, they all add to be 1,110. Okay? I know it's kind of confusing with all the symbols and the Greek stuff. Don't let it throw you off. This is the rule. You start with this one. This will be your first term. Plug it in. This number is your last term. Plug it in. All right? And then you put those two right here for the first and the last. And whatever your last term was, that number, that n, is what goes out here. And then it's an easy little formula. Okay? We're going to do one more. And this will actually be our last example for the day before you work on your practice. So we got to first find the first term and the last term. Okay? Got to find your first term and your last term. Now, what am I starting with?
You gotta start with the negative 1.
1. So, a sub 1. Here's my rule. Negative 2 plus 4 times 1. My rule is what's in the parentheses, and you substitute your I with what they say for I.
It'll be 2.
Right. So 4 times 1 is 4. Negative 2 plus 4 equals positive 2. So my first term is 2. And my last term is what? What's n equal? What's on the very top of my
28.
sigma? So the 28th term is going to be negative 2 plus 4 times 28. And what's 4 times 28?
110.
Yeah. What's 4 times 28?
112.
So negative 2 plus 112 is what?
110.
110. So there's my last term. So then after you get your first term and your last term, you come over and you do S sub n equals n times a sub 1 plus a sub n divided by 2. And this is the first term. This is your last term. This is your highest term you got. So my n is 28, because that's the number on top right here of my summation. 28 times, what was my first term?
2.
Plus 110 divided by 2. And then 2 plus 110.
112.
And what's 112 divided in half?
56. What you doing?
Not be so ugly. Okay, so 112 divided by 2 is 56. And then you multiply those two together. 28 plus 56 is what? I mean times. 28 plus 1,568. So the 20th, it's supposed to be 28 there. I don't know what happened to my pen. It didn't do right. So if I add all the terms
You're gonna get 1,000
from 1 to 28, I get 1,568 as the sum. And that is all I have for today. I'm going to stop recording my lesson now. This concludes section 12.2.